Okay, in today's positive math session, we're going to look at recurrent solutions, and we're going to look at the first video on that. This is going to be a fairly short video, just introducing how they look and how we can work through them. Now, recurrent solutions are just a form of sequences, and we've seen many sequences as we've gone through. So you've maybe heard about the Fibonacci. You've also done simple interest and compound interest in Nat4 and Nat5, and many others that are just form of sequences. So recurrent solutions are just a special form of a sequence. And sequences generally are about rules. So you do something to find the next amount, you do something else and you find another amount. With compound interest, we learned a rule that we could go straight to year 4 or year 5. But with recurrent solutions, we have to do it in steps. So a recurrent solution can look like this. So your UN plus 1 signifies the amount you're finding. Your UN is your previous amount or your original amount. And then you've got A and B that are making the rules. The UN will be sort of the initial value. So it might be, if you put money in a bank account, it would be the first amount you put in, that would be your U0. You then might want to make a rule to find the amount in it at the end of year 1. So your UN plus 1 would be year 1. If you're then wanting to find year 2, you would use your year 1 value in order to do that. And if you wanted to find year 3, you would need your year 2 value to do the rule. So you always need the previous value in order to go on and find the next value. So it can be quite time consuming. You will be having to use a recurrent solution that takes this form. You will be having to form a recurrent solution that takes this form, as well as finding out another couple of facts about recurrent solution. In today's video, what we're going to look at is just using the rule, okay, and finding, say, U1, U2 and U3 given U0. Now, this doesn't necessarily need to be a U, but it needs to be the same in both. So it could be a VU, so Vn plus 1 equals AVn plus B. It could be Bn, whatever. It would just be whatever the n plus 1 is, you would use the same letter, but it would just be n over here. Okay, we've got 2 examples to look through. We've got example 1 to do first, and I've got a calculator here just to make things easier. Okay, now remember, show a decent amount of working when you do these. We don't want to let the examiner think we're not putting the effort in and we maybe make a silly mistake because we haven't put the right amount of working in. So please remember to put an appropriate amount of work in. So here we have the recurrent solution that we're using. We've been given the original U0, which is equal to 10. And then we've been asked to find U1, U2 and U3. So obviously we need to find U1 first, then U2, then U3. So to find U1, obviously your UN would be then your U0. I'm going to write this longhand for this bit. And you'd add your 12. Now you don't need to write this every time, I'm just showing you where it comes from. Okay, so this would be 2 times 10 plus 12. 2 times 10 is 20, plus 12 is 32. We are now going to use that amount going forward. So for U2, it would be 2 times 32, because that's our U1, plus 12. 2 times 32 is 64, plus 12 is 76. Last time they wanted us to do it to U3, so one more time. And obviously this time we're using the U2. So 2 times 76 plus 12. Remember, you can write sums at the side if this was non-calculator. If it was calculator, you could do it on your calculator. I'm just going to do it in my head. 2 times 76 is 152. 152 plus 12 is 164, and that's my final answer because they wanted me to go to U3. Okay, so that's the first one done. The next one, there's our rule, un plus 1 equals a half un plus 4, and our original u0 is 20. So first of all, we're going to find u1. Once we find u1, we'll go on and then we'll find the next part. So it'll be a half times 20 plus 4. You can either put a dot or a times sign. Put times sign because that's what I did before. Half times 20 is 10. 10 plus 4 is 14. That is now our next value that we're going to use next time. So u2, a half times 14 plus 4. A half of 14, which is 7 plus 4, which is 11. We're now going to use 11 going forward. So u3, a half of 11 plus 4. A half of 11 is 5 and a half. 5 and a half plus 4 is 9 and a half. You could also write it as 9.5. I would prefer this one just because the formula had a half in it in fraction form, so I quite like it. Okay, so fairly straightforward. Take your initial, so your u0, put it in, find your u1, then find your u2, find your u3. There is a quick way to do this on the calculator. However, it's not actually that time consuming once you get in the habit of it, and if it's in non-calculator, which it could be, you're not going to have the calculator there to do it faster. Okay, plus you also need to show a level of working to show you understand what you're doing, and that if you make any silly mistakes, you're not getting over penalised. Okay, the you try section. Okay, so next two I'm going to give you are for you to try. So if you want to pause the video in a second, go through it, and then unpause your video, and I'll go through the answers with you. So pause your video now. Okay, so we've got the first one here, un plus 1 equals 3 un plus 4. We've got our u0 value, and we've find u1, u2, and u3. I'm going to use a calculator for this one, just because it's not that nice a number. So u1 equals 3 times 17 plus 4. So 3 times 17 plus 4 is 55, and that will be our next value. Our u2 will be 3 times 55 plus 4. I'll just keep that in my calculator, so times 3 plus 4, 169. And then lastly, because we've got to do the u3, 3 times 169 plus 4 is 511. If you did it without calculator, well done. If you used a calculator, that's okay as well. But remember, if you're doing it non-calculator, you can just write sums at the side, and this would have actually been okay to do if you were doing sums at the side. But for speed, I've just done it on my calculator. Okay, so let's do now the next one. A quarter of un plus 7. So un plus 1 equals a quarter of un plus 7. So first of all, u1 is a quarter of 12 plus 7. A quarter of 12 is 3. So 3 plus 7 is 10. u2, quarter of 10. So I'm going to use my calculator this time. I know a quarter's 0.25, so I'm just going to use it as that. Plus 7 equals 9.5, or 9.5. u3, a quarter of 9.5 or 9.5. Add the 7, our final answer is 9.375. Doing that on the calculator. Okay, which is the same as 9 3/8. Either answer is acceptable and we'll get you full credit. Now, if you go on and just try the few examples on the example sheet at the end, remember to pause it, and then once you're ready, unpause it and the answers will be there. Today's was just a short video just to introduce it. Next time I speak to you, we're going to do making the recurrence relations. So again, another short video, as recurrence relations kind of lends itself better to little short bursts of video rather than when we did the straight line, they were quite long videos. Okay, on you go and have a go at the worksheet, and I'll speak to you in the next session.